start to tackle the main controller that was giving this issue. And I also will feed the other controller where it's the wires have pulled out from the outer protective layer, drawing a blank, what I actually call it. Well, it really doesn't matter, words, just words. We're going to open up this controller. Would say shielding, but it's not necessarily shielding this in here. It's just rubber. I'll open up this controller, and I suspect, you know, as I mentioned before, that the sorry about that. That the controller pad is just fine. Okay. Just making sure everything is still in place. No clicky bits in here and stuff. Suspect there's no issues with the D-pad or anything of that nature. I suppose what I can do is clean these things up a bit. But what is an issue is these wires, mainly, more than likely this white one right here. I'll zoom in a bit. It's barely holding together by a couple strands. And it goes to this printed circuit board, its through hole. You got some diodes, resistors, a couple transistors on there. Board is relatively simple. I don't have a regular Super Nintendo to compare the insides with, but I imagine it's fairly similar. Well, what we can do is continuity test on a couple things. Imagine that we can do a continuity test from this side to that side. Now, I will say that I did go ahead and take apart its clamshell. It was a little bit finicky to work with. And the way this was manufactured is the clamshell itself was super glued together around these edges. So I just took an X-Acto knife and started in a corner and started coming down to break up that super glue a little bit around one side and then around the other. And then I was able to take a small flat tip screwdriver and start prying this apart. However, I will say be careful because you'll see that you have these openings on this side, these holes. And it could have just also been because super glue was around the entire edge. And then on this side are your pegs that go into those holes. So if you pry backwards, you'll break one of those pegs off. Should be able to tell what goes to what. Here, so we've got, see, 4 wires, white, blue, yellow, red, white, blue, yellow, red, and black and brown. And it appears that there's no center pin here. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So it'd be easy to just pin out from here to here, see if we lost some continuity. on those wires, which I suspect we have, because it's very intermittent. And an intermittent issue could be presented if your voltage or your ground out is not at the desired voltage level or ground reference. You would have intermittent issues. I'm going to make myself a little test lead that I can jam down here. That should be brown wire. And we'll go, brown goes to ground. Let's test it out. I've got 0 ohms resistance on my multimeter. I'll zoom back out. And took it down to 200 scale. So I'm seeing 2.5 ohms of resistance. Probably some because of the electrical length of the wire itself. Let's check the black wire, which is going to DV. About the same thing. 2.7 ohms of resistance. Alright, next we'll check red. And about 2.5 ohms of resistance. Yellow. Two and a half ohms, yeah, about 2.5 ohms. Blue. Slightly higher, 3 ohms. And let's take a look at this white wire. And 5-6 ohms. Substantially different. I wonder what happens if maybe I can get this somehow to, so I need a third set of hands. Put some pressure there, some here. And I'm just going to wiggle that around a little bit. You see my impedance changes, breaks apart. Came off. And impedance value is definitely changing as I twist and turn on this. So that's what we're going to repair. Alright, so as you can see, I've removed one little segment from here from the wires exposed and more, and I put a zip tie right at the end. So now if it's pulled through, it's going to stop at that zip tie versus that's going to help give a little strain relief on the wires inside. Now I'm going to use two types of epoxy. One some Loctite that I'm going to put around here to help seal this up. The Loctite is its properties are more like a more similar to like a rubber cement than a super glue. It's going to act as a buffer for this cable, as well as keeping moisture out and preventing the cable itself from, hopefully, from further damage once this clamshell goes back on, so it's not eating away at the protective outer layer that the wires run in. And then the second glue I'm going to use is a little bit of super glue. Just around the edges of the connector like last time. Now I'm not going to coat the entire connector, but only put some in some select spots, just because I want to make sure that this thing closes up and has a decent seal. But in the event I have to come back into here at a later point, which I hope not to do, I don't want to have to completely destroy this connector just to get into it. Okay, so with that in and glue, this is going to take about 24 hours to fully set, I believe. Let me see. Yeah, sets in 30 minutes, cures over 24 hours. But got that in place, and super glue is on the other plastics. So let's go ahead and get this clamshell back on. Yeah, I got a little bit of super glue on my fingers. While that glue sets in, so let's use a little bit of packaging tape. Help hold it in place, which we will remove later. Alright, so this is done. It'll take a little while to cure. We'll put it out of the way. Now on to the other side. So again, there's a break in that white wire there. I'm going to trim this back about 2 inches and feed it through this entire cable, and we're going to need to solder and desolder the older wires. So I'm going to turn my soldering station on, and soldering iron will set to, and what should we set to? Set it to 480 degrees Fahrenheit. What I did is I used my X-Acto knife and carefully made shallow incisions into this, not sinking in deep enough to penetrate these internal wires or accidentally cut into them by any means. Now should be able to slowly and carefully pull the wires through. So once we got these pulled through, should adhere and close up that cable a little bit. Right, so I've got these wires pulled through, and this rest of the cable now butt rested up with where the tensioner goes in, or this area that's supposed to hold all the tension when pulled onto it into the controller. We'll need to trim back each of these wires and get them tinned. Let's see, can we focus? There we go. We'll trim back each of these wires and get them tinned. Yeah, oftentimes it's very good to write down those and document everything so you don't run into issues later on working on a product, trying to repair it. Hey, my soldering iron has been thoroughly heated up. There's one. Two. Three. Four. 5. And 6. Alright, we can expect that's cleaned up fairly alright. Get some IP on there, get rid of this flux. We should be able to tin up our wires now and feed them through. Alright, so I went ahead and did the first 2 wires off camera, and all of them have been tinned up. But so basically what I'm doing is taking the tin wire, see, we went blue, yellow to red, feeding it through the back of this board, and I'm just kind of holding it in place with my finger. Then on the front side, getting a little bit of solder on my soldering iron tip, and then I'm applying it right to the front of the board, and I'm letting the heat do the job and draw the solder down through the hole. To make that connection and onto that pad. And I'll go back through and trim all these up. We got red, brown, okay, brown's on. Next we have white and then black. So while you saw me trimming it, the braid of the wire came apart at the end when I was trying to tin. You really want to try to keep the wire braid intact. Alright. So it looks like... So I trimmed it so I can fit it through the hole. And it looks like we have all of our connections made. Now I just made a bit of a mistake, and I'm not afraid to show you this. When I was using my flush cuts, instead of cutting, I pried and lifted this pad from the board a little bit. Now the pad hasn't physically broken from its trace on the board, which is fine, which means that there's still going to be connectivity between this wire onto this pad and through this trace. It's good, it's not broke. But what I'm going to do is clean this up and put a little bit of super glue underneath here, or you could use nail polish if you have some nail polish at home, and just re-adhere the pad back down to the PCB. So I want you to take notice of something else that I noticed. So recall I said that I lifted up this pad by accident, but also noticed that there was a run missing from here to that pad. Now I'm not sure if that happened while I was cutting, or maybe it while I was cleaning, that's when it came away. But what matters is, when you make mistakes, sometimes they can have substantially huge consequences, and sometimes maybe not. You just need to take a step back and slowly think how you can go about fixing it. I haven't put any glue down underneath this yet because I need to do some more soldering. So what I'm going to do is I'm going to take a small piece of wire and solder it to the top of this pad here, along with the ground pin that's leading out, and then probably around here somewhere I'm going to scrape off, or I could solder it directly to here if I wanted to, and I'll probably just run a jumper wire from there to there and then keep this out of the way. Instead of scraping off at the board, the solder mass, whatever's down protecting this layer, I could just go to the soldering points and solder these things in. Alright, so as you can see, just put a jumper wire in between here to there. Probably tying it to like the trace right in here would have been maybe better, but we already have some open points, and I think this wire is long enough that I can manipulate it once I put it back in to keep it out of the way of, say, these pads over here, and it'll still function as it should. So I think I'll be okay. I want to briefly, I did throw in some super glue to hold that pad down after soldering this wire in place, and so I want to do a quick continuity test using my multimeter and setting it to the diode symbol, and just make sure that I'm getting contact between ground and the ground portions on these pads. Alright, someone was playing Cool Border, so I turned down the music a little bit. But I got the board cleaned up. I've got it back in place. You can see that little bodge wire I put in here has been routed up and over this way. Let's see, turn on the light. There we go. And that keeps it away from the directional pad over here. So it shouldn't interfere with the pad. So there's plenty of excess wire down here, and this device here acts as a strain relief. You can see that there's something on the other side that helps prevent this from pulling out. Loctite and put a bead of it around here to allow it to dry, and allow it to dry just to add some extra protection so there's no erosion right at this point, hopefully. That being said, I think we're good to go, and I can button back up this gamepad and at least enough to test it out. Here's a controller we did the primary repair on. You know, wires were exposed, and you see there's been enough time for that glue to cure. And we put a little bodge wire in there, cleaned it up. Hopefully it will work. This has been a little bit super glued back together. I did the same thing with the other controller here. No wires were exposed to this end, so I didn't feel like taking it apart and trying to improve it at this point. But we will plug them in and turn on a game, see how it works with that game. Alright, here's the controller, port 1. Let's see, zoom out for a second. Well, hold on a second, bud. We're going to check to make sure that this controller works. Alright, up,
it's
down,
rainbow.
left,
It's
down.
rainbow.
I think right worked as well. Yeah, right worked too.
Really, rainbow.
Oh, I picked the wrong level. Let me back out. Start select work. Let's go over here.
Rainbow.
Alright, pressing the Y button. No continuous roll anymore. That's good. When you hold down Y, you do a roll, and then you should be able to run, but it just continuously does rolling. It's not right. B button works fine. So let's hold down Y. Yep. Jump still working. Alright, A work. Hey, we'll call this good to go. I think we're good on this repair. Alright, there we go. Kids join a Super NES game. If you like this video, give it a thumbs up, like, share, subscribe. Of course, you don't really have to do any of those things, but hopefully you found this video entertaining. And as always, have a good one.